In this video, we're going to try and understand what it means for a function to have a limit. So I'm assuming you understand the concept of limits in 2D. Remember, in 2D, suppose you have a function f of x. The limits exist when if you specify a degree of accuracy, I am 100% sure that I can get to within your level of accuracy. So there exists a delta here. There exists a delta and a minus delta. Where, well, A minus delta and A plus delta. There exists a delta where within this region, I will always be within your specified level of accuracy. What that means is, you give me a degree of accuracy. Let's say the limit is L. You give me a degree of accuracy. Let's say you want it correct to within 11 decimal places. I am 100% sure that I will always be within 11 decimal places within this region here. There exists a delta here and a delta here, where within this region I will always satisfy your 11 decimal places. I will always be within 11 decimal places. So now extend the idea to 3D. So let's say this vector here, vector function describes this path here. So we said that the limit of the vector function as t approaches t0 equals L if when you give me a level of accuracy. So just like over here, this level of accuracy here is some sort of tolerance to within the true limit. So let's say this is you can think of this capital L as being a 3D a location in 3D space. So you can think of this, you can imagine this L as being, let's just imagine it as being 1, 3, and then 4 up. So you can imagine this as being 1, 3, 4 up, say 1 across, 3 across. So you can imagine this L as being a point floating in space. Just imagine as that. So imagine this L is this thing here. Is this thing here. Okay, so the limit, let's say the limit here is capital L. So as t approaches t0 from the left hand side and then from the right hand side. So if someone gives you a level of accuracy, let's say well, this epsilon here is like this epsilon here, which is your degree of accuracy. But in 3D space, you can imagine this as being, well, in the x direction it has to be epsilon. In the y direction it's going to be epsilon. In the z direction it's going to be epsilon. So you can think of this as being a sphere of radius epsilon. So if someone specified, if someone specified that, oh, you have to be within this level of accuracy, then you can be, if you can be 100% sure that you can get to within that level of accuracy, then we say that the limit exists and it's L. Okay, so just like over here, someone gives you a degree of some sort of tolerance over here. Here, because you exist in 3D space, you've got to imagine this is like a sphere, and you can, if you can be 100% sure that you can be within, always be within that level of accuracy, then we say the limits exist. Okay.